Assalamu alaikum and good morning, ladies and gentlemen. We'd like to begin our session. And first of all, I'd like to introduce you to Rao Hamid. He is the General Manager, Domestic Operations at Systems Limited, who will be our moderator for the day. Rao Hamid looks after the geography of Pakistan for Systems Limited in the capacity of General Manager. From sales to profit and loss, revenue, and cash flow falls under his domain. He has an experience of almost 2 decades under his belt, which includes working for MNCs like IBM. I request him to enlighten you all regarding how IBM Cloud Pak technology is one of the best platforms to protect people's rights, businesses, and their privacy.
Thank you, Fatma. Thank you for the introduction, and thank you everyone for taking out time for today's webinar. I'd also like to mention that you should feel free to send in questions on the chat box, and we'll address them as we go along, especially during the Q&A session towards the end. Now, we're honored to be part of the exclusive community of IBM. IBM, as you know, is a highly reputable tech company. It's recognized around the globe for its massive contributions in revolutionizing the digital universe of various contributions. And likewise, Systems itself has been a market leader for the tech world in Pakistan as the first IT solutions company of the country. Its seeds were sown more than 42 years ago, and since then, our company's rigorously made efforts to transform the IT landscape. Today's event is all about, as Fatma was saying, about IBM Cloud Pak for applications. And one thing which is important to know is that cloud application or cloud adoption is a key pillar in any digital strategy. This adoption involves many fronts, including cost, security, and data ownership. However, the basic pillar is the modernization of our applications and systems. They must be cloud native. This means that applications should be developed in such a manner that they can easily live and breathe on the cloud, be it private or public. Now, in order to reimagine the application development within organizations, it's vital to understand the role of containerization technology. For our session, I'd request Ovais Khan to share his thoughts in certain key areas. Ovais has been a key technology evangelist for over 15 years, and that's really how long he's spent at Systems so far. He has experience in setting up complex system architectures using process automation and enterprise application platforms and patterns. As the head of global integration services at Systems, he leads a team of 200 impeccable problem solvers to deliver solutions that meet the needs of now and tomorrow. So with that, Ovais, how would you define the impact of containerization technology on the overall digital transformation strategy of an organization?
Right. Thank you very much, Ra, for a very generous introduction. See, the problem is cloud adoption is no longer a thing for the future. Now, the question becomes that as part of your digital transformation strategy, we do not ask this question that whether cloud is the right fit for us or not. The question has now changed that when do we want to move on to the cloud? It's just a matter of time when all the organizations will be pushed to the edge to move towards a cloud native architecture and have that kind of agility built into their digital transformation strategy. In order to answer your question around cloud strategy, there are three pillars that any organization should look at in order to modernize their journey. This includes methodology, technology, and architecture. So methodology is really the way we do our work, the way we deliver our projects, the way we execute our projects. Technology is generally what kind of deployment architecture you're looking for, what kind of shared compute storage and processing resources that are available at your disposal in order to enable all those different ideas and innovation within an organization. And architecture is simply the way you build those applications so that the element of flexibility, scalability is infused from the day one. And this has to be a more linear approach. We've seen a more growing trends where the dependence on central ID is decreasing, and we see the emergence of citizen developers where business users are equipping themselves with low-code or no-code platforms in order to deliver those projects more rapidly. And that's how you match the speed of business with the business speed of IT as well. Traditionally, what we've seen is that if you go back 10 years back, you'll see our methodology was based on waterfall. We used to have this gigantic projects which is spread it over years, and you'll execute the projects in phases, and then you'll probably use, more importantly, you'll use the bare metal and physical hardwares, which were really limited in their capability to share the resources, and so it's very expensive to maintain and scale those resources. And mostly the architecture in terms of connectivity across application, it was point to point. So if you have 50 applications in your ecosystem, those 50 applications were talking to each other in a point to point fashion, and there was a whole concept of huge monolith applications, which were very lumpy application, and there are so many things that limit your flexibility in order to scale those monolith applications. So for instance, if you have a monolith application that does so many things, for instance, there is a service which provides the payment APIs, and then there is another service which provides the customer information APIs. Now, if you want to selectively scale one of those APIs, let's say payment APIs, you cannot do that. You'll have to scale the entire monolith, and that limits our options in terms of keeping in view the cost optimization angle and the resources required in order to provision that kind of infrastructure. Moving ahead, what we saw the emergence of all these different technologies and methodologies in architecture, and we saw the emergence of agile methodologies where we were using sprint-based methods in order to deliver projects faster, define shorter sprints, deliver the project, and then gather the feedback, incorporate that feedback, and then move forward with that approach. But there was still a missing piece. The operations team was not involved in the agile methodology, so mainly between the business users and the IT team, but the security teams, the operational aspects were missing from the agile methodology. From technology perspective, we move on to the VM-based architecture. So we introduced this really nice hypervisors, which were capable of spinning up new VMs and share the resources on the bare metal physical service. We talk about architecture that has evolved into service-oriented architecture, where you have a centralized enterprise service capability, the set of reusable services that were exposed to the external world as well as the internal application. So there was certain straightening on the P2P point of integrations as well. And in the modern phase, which is the core foundation of any cloud strategies based on DevOps, containers, and microservices. So DevOps is where you build the entire ecosystem, starting from business, including the IT and the operations, which include security and compliance aspects as well. So the entire ecosystem and suppliers and vendors and end users are also part of this entire loop, where you have the quality concept ingrained from automation perspective, right from the day project is conceived. And as far as technology is concerned, you see this is the really thing that we are talking today, the containers. You see the emergence of bare metals moving to VM, and now we have a container-based technology, which is another layer of abstraction on top of VMs. And we'll see during our discussion that how the container technology is powering the technology choices that we have. What you're really building in your ecosystem is repackaging your applications or reimagining your application in such a manner that they can be moved to the cloud, regardless of whether they sit in today's time, be it on-prem or virtual private cloud offering or any public cloud offering. Unless you have cloud-native architecture built in as part of your methodology, you're not ready to go to make that transition onto the cloud. And then obviously in architecture space, we see the emergence of microservices, where small fine-grained services which can be managed by independent teams, and they all come together and bring the kind of selective scalability that we're looking for. So in summary, your cloud strategy has a direct link with the three foundations, as you can see: DevOps, containers, and microservices. Now, the next logical question becomes that, can I do a pick and choose approach on these? So for instance, I take a monolith application and deploy it on containers and execute the project based on agile methodology. So that really limits your capability. So for instance, if you have a huge monolith and you deploy it onto container, you can't really achieve the runtime elasticity or selective elasticity feature that is inbuilt into the microservices architecture. So really, as an organization and as a CXOs and the application developers, we need to think about whether are we doing a lot of DevOps, are we still doing a lot of VM, are we still doing a lot of SOA? So this is the really transition that we're looking for. Rob.
Understood. Thank you, Ovais. Just a quick question. Is there a way to create visualization of how containerization can help bring cost benefits over traditional VM-based or bare metal architectures?
Absolutely. So what we're going to look at is that how does this VM-based architecture differs from the container-based architecture? And let me walk you through one of the examples. And this is a really crisp example. I've tried to keep it very simple in order to really show the variance between that. So what we'll do is let's say I'm a developer and I've created a Node.js application, right? This is my Node.js application, and we'll look at two form factors. First is the VM-based architecture, and the other one is the container-based architecture. And what we're going to do is we'll take this Node.js application and we'll push it into the VM-based architecture, and let's see how the resources, compute resources, look like. So let's see what's this big box over here. It's just a physical server, the hardware that you traditionally see. This is your hardware, and this is your host operating system that sits on top of hardware so that you have access to all those physical resources of that particular hardware. Then you have a hypervisor, and hypervisor really is software that lets you spin up different VMs on a particular hardware in the VM world. So in order to push this JS application, Node.js application, we'll need a VM, right? We'll need a Linux VM. So let's, and before that, once you've deployed the hypervisor and host operating system, you've seen that you've consumed some of the resources that are available in this particular hardware. So this indicates the consumption bar. Now what we're going to do is we're going to deploy this JS application into a VM, which again has its own operating system. So this is the guest operating system. So you see there's a duplication of guest operating system as well as host operating system, and this really consumes a certain amount of resources. And we'll also have certain essential libraries and binaries in order for the functionality of our Node.js application, and this is our JS application. Now let's see how the compute available resources look like. So let's say we've assumed that this particular VM has consumed these many resources. We still have this much amount of compute resources that are left. Now let's say we want to scale our Node.js application. So I'm going to go and create two more copies of the same VM. That's the typical way we scale our application, right? So I'm going to create two more VMs and same library. And one thing to notice is that, again, I need another operating system, the guest operating system in VM. So now I have 1, 2, 3, 4 operating systems, and these operating systems obviously consume the resources. So this is my compute consumption looks like. I have exhausted all the available resources that are available on the hardware, and I cannot scale this particular hardware further. Now let's look at how the same application deployed in container is going to look like. So again, so let's first talk about container itself. So in order to build a container, you need something called a manifest file. It's a description of what container is going to look like, right? And then you build an image of the container itself. So there is an image of the container in Docker world. This would be a Docker image. And then you have the actual container available. Now let's take this container and let's try to push it onto the another form factor that we see. Again, you have an host operating system, which is essential on top of the hardware. Now you have something called runtime engine. So for containers, you don't need hypervisor. Runtime engine, you can imagine similar to what hypervisor does in a traditional VM-based architecture. It allows you to reuse the host operating system resources to the containers. So let's assume we have taken the same amount of memory or shared compute. Okay. And then what we do is we deploy this, we push this Node.js application, which is part of the container, and put it into this space. The immediate benefit that you notice is that we don't need separate operating system for this container to work. The container really uses this runtime engine and runtime engine in addition, it uses the host operating system capability in order to access the hardware. So, and then let's scale it further. Let's have another container with the same Node.js application and another. So we have 3 containers over here. It's similar to 3 VMs we had over there. And you can appreciate the fact that there is no operating system involved in these containers, right? So let's say we have this much compute for each container, and you still have pretty much some amount of resources that are still left. With the same VM, with the same throughput that you were expecting from VM-based architecture, once you've deployed the same application on container world, you have the immediate benefit of these resources being freed up for you. And let's say now I have another application. Let's a third-party application, a weather service that I want to invoke as part of my Node.js application. So somebody in my organization creates a Python application, invokes the weather service, which is an external third-party API, and now my Node.js application has to invoke this Python service in order to access the weather data, for instance. Now in a VM world, I would be tempted to, take these two applications and put it in one of the VMs, right? So I'll have to probably discard this VM and take this and put it deployed over here, right? But what am I limiting myself to? So, if I want to scale this particular Node.js application, I cannot do that selectively. I have to scale this entire VM, which contains the Python application as well as the Node.js application, right? But in container world, what I can simply do is just deploy this Python application as another container, and that's it. And then you have some of the resources further consumed, and you still have certain resources left. So you see the measured benefit that you can visualize in terms of having a VM-based architecture and the container-based architecture is it's visible. You save those resources that you can use for other applications in your organization. So that's how you can really visualize the impact of the choice that we want to make going forward as part of our cloud strategy.
Ovais, thank you very much. That was certainly very, very insightful. I've certainly learned a few things today from what you just said. With that, I'd like to move on and introduce Asim Noorani. Asim has joined us from IBM. He's the technical leader responsible for managing the hybrid cloud integration portfolio in Pakistan. He's extensive experience in enterprise solutions automation integration in various industries in Pakistan and also outside of Pakistan. So Asim, again, welcome to the webinar. Thanks for being here today, and over to you.
Thanks, Rao. Thanks, Ovais. Thanks for the briefing. Okay, so a brief regarding how IBM can help in the complete journey to cloud for any enterprise. So I believe Ovais have laid up a good foundation regarding what containerization is and how it can help your applications. We need to understand what are the changes that we are going through in the case of journey to cloud, from monolith applications to cloud native applications. So we can see as of now, we have unique workload needs. Each application requires a different application server, different libraries, and different components in order to run. In the case of tomorrow, after the microservices world, we will be having a build once deployment, which can be deployed anywhere. It can be your private cloud within your on-prem organization. It can be a public cloud, which might be IBM Cloud, Azure, AWS, or any other cloud. Apart from that, we have multiple cloud vendors out there right now, and we have to pick and choose that what sort of vendors are most suitable for our workloads. In the tomorrow's world, after the microservices platform are regularly used, we will be having an open and integrated approach, whereby we can use the cloud vendors as per their capability and distribute applications among those cloud vendors. And we will have a clear visibility and governance and security while using it. And furthermore, we see a technology gap right now in the case of VMware world or virtualized world. What we are looking forward to a culture and skill transformation so that we can apply the best practices and proven methods in order to run our cloud native workloads on a proven platform. So these are a few of the changes that we can expect coming in the future. Now, regarding building and modernizing the applications, right now we all are aware of monolith applications and databases, whereby we have either 2-tier or 3-tier applications, which eventually starts from small application and end up to a large complex application, which are difficult to innovate or manage. What cloud native architecture says is that we adopt to a microservices approach, whereby we break up these monolith application to microservices so that they are easier to manage, easier to innovate, and easier to scale. In regards to the service delivery, right now, the development is inefficient because there are so many roadblockers in terms of operation and the development delivery. We can innovate and leverage on the refactoring of application, and then we can be much more agile as compared to what we are today. And it's all about breaking up the siloed organization, whereby we have different departments for different use. What it says is that we need to have a high performance agile culture team which is able to run the complete DevOps and data management operations that are required for continuous delivery. So it's a methodology that has proven itself within the industry. And as per IBP study, it says that those organizations which have adopted to a microservice architecture have seen an improvement of at least 69% in terms of their operations and scalability. Apart from that, they've also witnessed 63% of growth or improved performance within their employees. So how IBM can help you? IBM can provide you with the end-to-end strategy, which includes the high-performance cultured agile architecture in which we can help you in order to adopt the DevOps methodologies. We can help you in guidance regarding the adaptation of continuous delivery and continuous integration architecture or culture within your organization. And it's not only a technology shift, it includes a cultural shift whereby development team, the operations team, and security teams are a part of single team that are running towards a goal in order to deliver a high performance application. It's all about the culture change. Apart from that, we bring you industry expertise and insights. We understand your enterprise application and recommend you what sort of changes are required in the monolith application in order to make them modern application and on the cloud native architecture. Apart from that, we can provide you an end-to-end platform. Since your single application is obviously going to be bifurcated into multiple microservices, you need a proper platform in order to run those microservices. So IBM provides you the foundation on which you can deploy your modern cloud native application on a much faster and lower cost. So just briefing you about one of our cloud packs, which is Cloud Pack for Application. If you just look into the offering, it's an end-to-end offering whereby we have IBM certified container software on which you can run your workloads. For example, we have different development tools, application runtimes. So if your runtime is based on Java, Node.js, PHP, Python, we have the application runtimes for them. Apart from that, we have the modernization toolkits. So in case if you are running any Java workloads, we have toolkits which can go through your code, which can analyze your code and suggest you what sort of changes are required in this particular code in order to have it cloud native. We have the right DevOps tool in order to run microservices and manage them from the development and the operation perspective. It's an enterprise-ready platform which is being used by many enterprises within the globe, providing you a self-service portal so that the tasks are easier to perform. All of this lies on a common operation services layer, which handles your logging, monitoring, security, identity, and access management requirement, which is the key for each organization. All these foundations lie on the Reddit OpenShift, which is a proven platform in order to run the microservice cloud native applications anywhere. It can be rather IBM public cloud, it can be AWS, Azure, Google, or any edge device or your on-prem systems. So this is the reference architecture. As we can see, there is a unified experience layer, user experience layer, whereby the end user can use these tools, which include the developer tools in order to develop cloud native applications, the runtimes, the modernization toolkit in order to modernize your monolith applications to a cloud native application, the DevOps tool. All of this is unified through a unified user experience, which make it quite easy to use this particular platform. We have the self-service portal through which this unified user experience is provided. And apart from that, there's integration to various other open source or the proprietary tools through which you can integrate this cluster tool. Last but not least, this everything is based on the secure engineering that is provided by IBM, and it's based on OpenShift, which can be deployed anywhere, even on the edge, on-prem or cloud. So this is the whole reference architecture for the Cloud Pak for application. So what IBM is actually doing is that IBM is combining all their offerings in terms of Cloud Paks. For example, Cloud Pak for application is a Cloud Pak which helps you modernize your monolith application and deploy your microservices cloud native application on a IBM containerized platform, which is based on OpenShift along with the common services that IBM provides. Cloud Pak for data is there to fulfill any of your data related needs or analytics related needs. For example, machine learning, big data, or any other requirement within your organization. Similarly, Cloud Pak for integration provides you the integration capability. It can be integration capability within your organization. It can be in the form of open APIs. It can be in the form of Kafka, MQs, or any other mechanism through which you need to integrate your B2B applications, which might be within your premises, or it can be an integration with a third party over the internet. Similarly, IBM is offering for Cloud Pak for automation, which caters to all your automation needs. For example, your business processes, your content-related capabilities, your capture-related capabilities via OCR, ICR, or your rule management capabilities, so that your business users can actually manage the rules and make the decisions on the fly. And on top of that, since we can foresee that in the case of this microservices, you will be ending up with multiple clusters. It can be a Kubernetes cluster, OpenShift cluster, or your VMware cluster. So you need a single environment in order to manage it out. So Cloud Pak for multi-cloud management is the platform through which you can manage these multiple clusters, govern it in a single window, and provide the DevOps that is required in the case of microservices architecture. So IBM have defined a methodology in order to assess the workloads. You first need to identify, because all of the workloads are not a good candidate for the cloud native architecture. So you need to identify the workloads that are good for the cloud native architecture. There can be different entry points. For example, there can be different business drivers. For instance, you need to lower the deployment cost, or you need to have further flexibility. You need to move your workloads from on-prem to cloud. So there can be different business drivers. There can be development drivers in terms of using more open technologies or more latest technologies, or have the DevOps in place, or it can be an operations environment whereby you need to streamline with the agile development practices and adopt to the flexibility that the business needs in terms of their business applications. So how you achieve is, first you identify the value driver. There can be different workloads that might be running within your organization. So as a first step, you need to discover that what sort of applications are running within your organization, and which of one of them are a better candidate for the cloud native architecture. So first, there is a phase of discovery whereby you identify the best candidates for the cloud native architecture, and then you have the transformation analysis, that how easy or how difficult it is to break the application, the monolith application, to a cloud native architecture. So we have the relevant transformation analysis tool, which can guide you and transform those particular workloads from monolith to cloud native. And then you have a cloud affinity analysis there, whereby you decide which cloud is best for your workloads. And then you have a approach and planning phase, whereby you define that how are you going to transform your monolith to a microservices architecture. And it is usually in a wave-based approach, whereby you break that particular application one by one from different business perspective, from monolith to microservice. So IBM can help you in this particular approach and planning phase and the execution phase, whereby we can identify and make the required changes in order to have your application cloud ready. And we can help you in deploying those applications either on your public cloud or private cloud as per your need. So how does this Cloud Pak for application helps you? it accelerates the whole modernization story. There can be different use cases. For example, you might want modernization toolkits and DevOps in order to provide consistency and control. You need a single environment whereby you can control everything, but you do not want to limit your development team or the operations team. So it provides you a platform which provides you consistency and control across the environment. It provides you a platform whereby you can deliver a single customer experience using the development tools that are available within the platform. And it provides you speed modernization by handling multiple clouds and multiple vendors in a single pane. So it helps you through the modernization toolkits. It helps you through the DevOps. It helps you through the self-service portal and the application operations management features that are available within a single platform with the name of CloudTech for Application. So IBM helps you in modernizing your existing investments. You can leverage on your existing application investments, for example, WebSphere, your coding skills, your licenses that are available within your organization. We would definitely like to get into a discussion with you in case you are interested around it. It provides you the investment flexibility. So in case if you pick your CloudPack for application or integration, the flexibility that you have is that you can use any of the features that are available within that particular platform, within the entitlement limit that you have. And leveraging the open standards, it provides you a future-proof investment and new capabilities as they emerge within the market. These are few of the enterprises which IBM have helped during its journey. American Airlines is one of it, who have migrated their complete workload from VMware-based applications to cloud within 4 months, and they have received operational efficiency and development flexibility after moving their workloads from VMware to cloud within these 4 months. If we talk about Westpac, they have modernized their applications, and now they are 10 times more faster and three times less expensive as compared to the previous monolith applications that they were running. If you talk about Bradesco, they were able to onboard 3,000 new clients in a day by using the AI and the mobile banking capabilities, which depended on the underlying CloudPack capabilities provided by IBM. In case of Hertz, they have gained consistency and control across various services deployed on Amazon using the CloudPacks. So just in order to summarize what we have discussed, basically there are 3 differential points that CloudPack for Applications or the CloudPack provides. It provides you a modernization readiness platform through which you can assess your applications and modernize your application. You can deploy it anywhere you need. And it can be within your own data center. It can be on any other public cloud. It provides you with the integrated common services for observing and diagnosing the workload that is running over there. And the tools that it provides are various developer tools in order to develop cloud native applications, support for various runtimes, for example, OpenLiberty, Node.js, Python, PHP within a single platform, the modernization toolkit so that you can modernize your monolith architectures to the modern architecture. It provides you the right DevOps tool in order to execute your CI/CD in a purely DevOps cultured fashion. It's enterprise ready, it is proven, it is tested within various enterprises around the globe, and provides you a self-service portal so that your developers are free to access the resources they need, and your operations stream is now more vigilant in handling the containers rather than looking into the workload that is running for the enterprises. So I guess so that's it from my side. Any questions or will be welcome.
Yeah, I think for questions, Asim, we'll wait till we're complete with the remaining presentations. Asim, thanks again. You know, thank you very much. Again, it was very, very insightful. And as you and Ovais have eloquently summarized, you know, it's not about when or it's not about if you're going to move to cloud technology platforms. It's about when you're going to move there at the end of the day, and how quickly you're making your organization capable for that transformation. So, with that said, I'd like to introduce Hamad Rehman from Systems. He has an accumulation of about 15 years of experience in diversified ranges of technologies, including analysis, administration, implementation, migration. And he's also delivered very key projects in the US corporate industry. So Hamad, if you could run the demo, please. Thank you.
Hi, everybody. My name is Hamad Rehman, and I have been working with clients to provide solutions for their integration needs for about 15 years. Our main purpose of today is to show a small demonstration on how we can leverage IBM Cloud Pak for integration and step into application modernization. I'll pick up one component of IBM Cloud Pak for integration that is called App Connect Enterprise and demonstrate how to deploy applications on it and how we can benefit from horizontal pod Autoscaler. Before going into the demo, let me give you a brief description of HPA, which is the horizontal pod Autoscale feature. HPA is a feature in Kubernetes which takes care of dynamic scaling of pods on worker nodes. This can be achieved just by running a small command at any time. We can define the minimum and maximum number of pods to be running at certain time. We set the number of minimum instances for normal workloads, and we set the maximum number of instances according to the highest workloads that can be achieved. HPA would spin up more instances of applications on worker node as workload increases. Now let's move on to the demonstration first and see how we can deploy integration applications on App Connect Enterprise. I have created a sample application and let's deploy it on App Connect Enterprise. For that, we first have to go to the App Connect Enterprise dashboard. And over here, we can just create a new server. For this application, we can select a bar file or the application which is already uploaded, or we can add a new bar file or a new application. For now, I just pick up the already uploaded application and press continue button. Over here, you just click next, and you will be asked for whether the application was designed on Toolkit or it is designed on App Connect Designer. So my choice is the Toolkit. I click next here. To go further, I just click on the on button over here to show everything, all the details. I just give a small name of the application. In details, nothing else to be filled for right now. Over here is the path of the Docker image for App Connect Enterprise. This is the service configuration for this application, in which you can set the ports for HTTP request and also ports for HTTPS request and also for Web GUI. And over here for the configuration for deployments, you have the replica count. By default, it creates 3 replica counts, but for now, I just reduce it to 1 replica and just click create. And now we have to wait for some time so that the application gets created, integration server gets created, and the container just spin ups. So the dashboard just came back, and we can see that there is the integration server created with the application, but it is unavailable right now. We just have to wait for a container to spin up. We can just go back onto the Red Hat OpenShift container platform administration console, and we can see if you go onto the pods, you can see the new pod is just created and ready. The new deployment is also ready. Under networking, we just go and click on the services. A new service is created, and this is the route which is also created for it, so that we can access the application outside from the OpenShift cluster. Service is the access to the application from within the cluster. Okay, the service can be achieved from the cluster, and the routes that gets created, it can be achieved, or it can be accessed from outside of the world. Well, let's go back to the dashboard and see if the integration server or application is available or not. Just want to refresh the dashboard. Here you go. As the dashboard refreshes, and we can see that the AC 2020 is now started, and it has one replica set running, and required is also one replica set. So we go back to the OpenShift container platforms dashboard, and then click on the routes and take this. See, we just copied the route URL over here and just appended the application, and we can see, click over here, we can see that we can get the application over here. Okay, now we see that the application is running. I can also copy the URL and just copy the URL and just create a new SOAP project in SOAP UI, so that I can access the application. Just see, this is the small request. Just fill up the and you just hit the application, and you have received the reply from here. Now I would go back to the OpenShift platform container platform administration console and go onto the pods. I'll show you. This is the pod which just spun up for this AC 2020 application. This is the deployment of the same application, AC 2020, and you can see that the status over here, one pod is running out of one pod. Now we have now I have to go and show you how we can autoscale it, how we can set the minimum pods that are required, and how we can uh, set the maximum number of pods. For this, I just go to the CLI mode and see run the command OC get pods within the same namespace. Okay, so I'm within the same namespace, and I just got the pods which are running. This is the pod just created, right? And then I can also get the deployment. Okay, this is the deployment got created for this application. So to enable dynamic auto scaling, I just we just write the command of OpenShift OC autoscale deployment, give the maximum number of replicas and minimum number of instances that can be set. And we can define the percentage of CPU. Maybe you can define that if the CPU of the container goes beyond 50%, right? The another replica set should be spin up. Another container spins up, and then the name of the deployment, right? Let's do this. Copy it. And just go on to the CLI. And then so now after the command is complete, just hit it. So the horizontal port, actually the HPA is created. You can see for Autoscale. You can say get HPA. If you type HPA, you can see that the HPA is over here. Also, we can say OC describe HPA, and then name of the HPA. It will give you, so it will give you, see how many percentage of CPU can be set, minimum replica set, and maximum number of replica set is set here. So now let's go to the SOAP UI and put some load on the application so we can verify that by putting loads and increasing the CPU request of the containers, Kubernetes will spin up more containers automatically. Let's put some load on it. Start load. So load is getting generated on the application. You can use any kind of application to put for load testing. Let's go to the application. We see that the 5 pods are just now spun up. Over here you can see, that one container is just spun up. It's not yet ready. The other container just gets created and ready to serve the request. We can also go on to the dashboard over here, which is the Grafana dashboard, uh, which we set over here for you guys, and you can select the workload application that we created, and you see the CPU usage, and you can see each container that just spun up because of the workload gets higher, and you can see the CPU limits and CPU usage, CPU request, and also you can go down there and you can see many things For example, current network usage for each pod, bandwidth usage during this load testing. You can see the memory usage for each container over here. Now you can see the load testing is finished, and now we will see that the HPA would reduce the number of pods back to the normal. Let's go back to the OpenShift platform administration console over here. I think we need to wait. For pods. After some time, these pods will get back to the normal requirement. To number one. So now here we can see that only one container is running. The rest are just destroyed. Gets destroyed because the load that we put just went away now. So this is the HPA, which is the horizontal pod autoscaler demo, and which is very important when we go into the production environment, right? If you deploy the production environment and we want to leverage this horizontal pod autoscaler, this is very great from the Kubernetes and OpenShift. I hope that you guys enjoyed this demo, and thank you for joining, and thank you for having time spared for my demonstration. Bye.
I'm going to move on to the question and answer session.
One of the questions that I may get a lot from our customers, and I think Asim can shed a light on this one as well. But what are the things to look at when starting your transformation journey? We've talked about some of the workloads, but if we can specifically talk about the Pakistani banking and telco space, because those are the ones really forward in transformation journey. You can talk about some of the use cases that you have witnessed in your experience. I think that'll be some point to start for the participants.
Yeah, I think so. That's a great question. Basically, let's take an example of the banking industry within Pakistan. So the workloads that we look forward to in order to modernize are those workloads whereby they are facing the challenges in terms of operations. For example, there are two diversification in the workloads that is running in the banking industry. So if we take an example, there is a digital banking platform and there might be a core banking application. If we compare both of them, in the digital banking platform, we can see that there is a high frequency of change. There is a high frequency of change. There is a much need of new technologies so that the user experience can be made much better. There is a high scaling requirement. The load on the digital banking platform can be much higher in case there are any bill payments or in case there are any busy periods. So there is high scaling requirement within it, whereby the load can grow and lower down in instances. So these are the workloads whereby we can leverage the container-based platform. We can have the DevOps culture in place so that the changes are easy to make and deploy and execute. And then we have the underlying scaling capability of the Kubernetes platform so that in case the load comes in, the application can scale automatically up or down as per this scaling requirement. And the operations are quite much simplified. And if we look into the monolithic application like core banking, the changes are not that frequent. The scaling requirement is not there. So apparently, if we compare these two workloads as an example, digital banking can be one of the use case best which can be a best candidate for the microservices architecture, whereby core banking might be the one use case that we will take somewhere down the road, least in the line. So this is one of the examples in terms of banking. Similarly, we have different examples in telco, healthcare, or retail industry, whereby we have different workloads with different requirements.
And I think it's fascinating the amount of data that's being produced. And I was just going through one of the stats by IDC, and they've said that by 2025 there will be like 163 zettabytes of digital data that will be produced worldwide. And to put things in perspective, 1 zettabyte is equivalent to 1 trillion gigabyte of data. So the growth in the production of this such a huge amount of data and the kind of computing capacity that's required in order to process that data and create the personalized experience from the end user, I think the opportunity is limitless. And really, you cannot do that without having cloud strategy as part of your transformation journey. So I think that's the essential part, and that's where everybody needs to look at in their organizations.
Exactly, I agree. And looking into the data and the compute requirements that are growing, we can see various other technologies that are emerging, like 5G technology. So right now, one of the areas that might not be in focus will be coming into focus in near future. For example, edge computing. So that the data that we are producing, we might be filtering out that particular data rather on the edge devices rather than bringing on the server. So we need the right strategy in order to manage that workload that's coming in along with the data, so that we can further filter and properly accommodate that particular compute and the data requirement that is coming in near future. And obviously, the digital side of the organizations is fueling this particular whole scenario.
Perfect. Makes sense.
So
Okay,
I guess so if there are any questions.
Yeah, I'm just about to wrap up. It's 1 p.m. as well. So thank you everyone who chose to join today. And thank you to Ovais and Asim and Hamad, Fatma for setting this up as well. And we hope to see you on our next webinar. So thanks a lot and take care and have a good rest of the day.
Thanks a lot.
Thank you, everyone. Thank you, Rob.